Neema Academy, transforming education.
Have you ever wondered why an object appears lighter when submerged in water, but the same object feels heavier in the air? What is involved in balancing the weight of a swimmer in a swimming pool? Or, how is it possible for a ship carrying thousands of metric tons of cargo to float on the ocean? Well, the secret to answering all these questions lies in the concept of upthrust. Hello students! Today you are going to learn about upthrust through this video on Neema Academy. Without any delay, let's dive into the topic. Let me give you an example that makes you feel buoyancy or thrust clearly. Let's take a ball and a beaker filled with water. Then, try to sink it in the water. What do you feel? Does it sink? Obviously, when we try to push the ball down into the water, we feel an upward force that tries to float the ball on the surface. Students, please think, what may have caused this upward force on the ball? That's right, water is the one that offers the upward force on the ball. Let's take one more activity that brings better clarity to understand buoyancy. First of all, let's take a brick, a rope, a spring balance, and a bucket. Now, we should tie the brick with the rope and measure its weight using the spring balance. The weight of the brick shown of the spring balance is 14.4 Newton. Later, we should fill the bucket with water and then measure the weight of the same brick in water. The reading of the weight of the brick shown by the spring balance in water is 6.9 Newtons. Students, can you guess what may have been involved in lowering the weight of the brick in the water? Yes, some upward force must have acted on the brick due to water, decreasing the downward acting weight of the brick. Therefore, the total number of upward forces acting on a wholly or partially immersed object due to the liquid is called upthrust. Moving back to our activity, we recorded the weight of the brick in the air as 1.4 kilograms, 14.4 newtons, and the weight of the same brick in the water as 0.705 kilograms, 6.9 newton. The difference in the weight of the brick in air and water gives us the value of upthrust acting on the brick due to the water. Thus, the upthrust experienced by a brick due to water is 14.4 Newton minus 6.9 Newton equals 7.5 Newtons. 7.5 Newtons is the upthrust provided by water on the brick. Students, I hope the previous activity has helped you develop the concept of upthrust.